Hello everyone. Today we are going to do the Cambridge IGCSE paper of class 10th held on 10th of Feb, 10th Feb in the Indian subcontinent, and this is a Feb March variant 2025, and the variant is 062042. This is paper 4, extended chemistry theory, and the first question of this paper is we have to write using numbers only, state the percentage of oxygen in the clean dry air. The percentage of oxygen in a clean dry air. This topic is from your chapter the chemistry of the environment, and in which the percentage of oxygen is directly stated in a tabular form, which says that oxygen is about 20.95%, which is about 21%. I can write 21%, exact is 20.95%. Nitrogen is 78.08%, and argon is 0.93%, and so on. So we will write oxygen 21% exact numbers. Typical operating temperature, second question is typical operating temperature in degrees Celsius in Haber's process. Now Haber's process is used for preparation of ammonia, and there the temperature required is 450 degrees Celsius, which is a fixed temperature for Haber's process, 450 degrees Celsius. Number of atoms in a diatomic molecule, diatomic means 2 atoms are there, the answer is 2. Maximum number of electrons in second electron shell, the first shell is K, second is L, K shell contains 2, L shell contains 8. How I find out? I find out by the help of 2n square formula, where n is the number of shells. If I say n equals to 1, then 2 into 1 square equals to 2. N equals to 2, then 2 into 2 square, that is equals to 4. 4 into 2 is 8. Therefore, the answer for this question is 8. The second shell will contain 8, and you should remember this formula, 2n square, which tells about the number of electrons in a shell. Number of electrons in a shell. Okay, and where n is the number of shell. Now, number of hydrogen atom in alkane with 7 carbon atoms. Alkane with 7 carbon atom, alkane is CnH2n plus 2 is the general formula for alkanes, as we all know. Now, if n equals to 7, then C7H14 and 2 16. This is the formula for alkanes with 7 carbon atoms. Number of hydrogen atom will be 16 in this answer. Number of particles in 1 mole in standard form. 1 mole always contain 6.02 into 10 to the power 23 particles or entities. Therefore, the answer is 6.02 into 10 power 23. Thus, I will get 6 marks for writing all these things. Now, the question 2. This question is about ionic compounds, and question part 2, part A is state what is meant by the term ionic bond. Now, ionic bond, as we know, is a bond between the positively charged ions called as cations and the negatively charged ions called as the anions. The definition for ionic bond should contain electrostatic force. So it is the bond which is due to electrostatic. This word is important for the answer. Electrostatic force of attraction between a positively charged ion that is the cation, positively charged ion, which is a metal ion, we can say metal ion or cation, and a negatively charged ion which is an anion or a non-metal ion or an anion, formed due to loss and gain of electron or complete transfer of electron from one atom to other. Formed due to loss and gain of electron, we can write. Okay, you can also write complete transfer of electron from one atom to other. This is the definition of ionic bond, for which I should get 2 marks if I write all this. Now, potassium sulfide K2S, B part is potassium sulfide K2S is an ionic compound. Complete the dot and cross diagram in figure 2.1 of the ions in potassium sulfide. Now we know that potassium K, configuration of potassium atomic number 19, as for your course 2881, K element shell 2881, and for sulfur atomic number 16 is also 2, 8 and 6, that is K shell 2, L shell 8 and 6 electrons in the last shell. As I see this diagram, the K will form a positive ion, there will be a positive charge here. Sulfur will form 2 negative ion, 2 minus and 1 positive here. Now I have to complete this. He's saying complete the dot and cross diagram in this figure and show the charge in the ions. The charges will be plus 1 to minus 2, there is 2 minus and plus 1. If I have to complete this table, then I have to draw one more circle, one more orbit around it, and that should contain, as per this electron will be lost because of K plus ion formation. Therefore, only 8 electron will present in the next shell, 2 to 4 to 6 and to 8. These are the K plus ion shell. Same way, one more K plus ion here, it will also lose one electron, and it will have 8 electrons in the last shell. 8 electrons in the last shell, 2, then to 4, to 6 and to 8. So it will also have 8 electrons in the last shell. Okay. Similarly, sulfur will accept 2 electrons in its last shell, and the last shell contains 6 electrons, 2, 8, and then it will have 6 electrons here. If these 6 electrons are from sulfur, we will represent them by a cross. 1, 2, 3, 4, 5, 6, and 1 electron each. They are coming from the potassiums, so they are represented by dots. They are represented by dot in a green color. So this will be the structure for K2S, potassium sulfide, where potassium is losing and sulfur is accepting 2 electrons in its outermost shell. Clear? Now the C part of this question is, ionic compounds are giant ionic lattice. They have a 3D lattice, as you all know, which of ions, positive ions and negative ions, in which a fixed number of ions, there is a fixed number of positive ions surrounds a negative ion. And since it is in sodium chloride, in it each Na plus ion, the sodium ion, is surrounded by 6 chloride ions, and each Cl minus ion is surrounded by 6 Na plus ions, and vice versa. Therefore, coordination number is 6:6. So we can say 6 chloride present around 1 Na and 6 Na present around 1 chloride ion. We have to complete a diagram to show ions present. Use plus for sodium and minus for chloride ions. 1 chloride ion has been completed for you. So this is chloride. Then around it will be a positive charge 1, positive charge 2. Each chloride ion has 6, 1 and 2, 1 this, 3, 1 below, 4, 1 this side, 5, and 1 upon 1 other side, that will be 6. So these are the 4 sodium ions. Then chloride ion again minus. Then this around this chloride ion there will be a positive ion, then it's a positive ion again here. Then around this positive there will be one negative ion here, and then positive attached with a negative. So this will be a diagram of NaCl. These are Na plus. Around each Na plus there will be 6 Cl minus. This side 1, this side 2, this side 3, and then next one more similar structure present here, and it will have 4, 5 and 6. So it will have 6. Each Na plus will have 6 chloride, and each chloride will have 6 Na plus ions around it. Therefore, this will be the diagram. Now the next question is, state the name given to any positive ion. Now any positive ion in an ionic lattice or anywhere, we call them cations, and in case of ionic lattice we can call them metal ions or metal cations. Okay. D part is, the ionic compound can be decomposed by the passage of electric current using inert electrodes. State the name of this process. The process called as electrolysis. Electro means electric current and lysis means breaking. So whenever you break an ionic compound, whenever an ionic compound decomposed by the passage of current, we call it electrolysis. Write the ionic half equation for the reaction which takes place at the anode when molten potassium bromide KBr is decomposed. Now when it's KBr, it will dissociate to form K plus plus Br minus ions. Now according to the theory, LOAP for an electrolytic cell, we should know this word. What does L means? L means left. The electrode on the left side of the electrolytic cell, on that electrode oxidation takes place. Generally it is left, but it is not necessarily left and right. It could be right also. LOAP में there is important thing is O and A and P, they are important. Left and right can interchange, but oxidation will always take place on the anode. A means anode and P means positive. That is the electrode which is present on the left hand side of the electrolytic cell. If I draw electrolytic cell and one electrode is on the right hand side and one electrode on the left hand side. On the right hand side, the left side will be my anode and that is positive, and the right side will be my cathode, that is negative. So this is my positive and this is negative electrode. The left side electrode oxidation will take place on it, and it is called as anode and it's positively charged. So when we talk about KBr, the negative ions which are my Br minus ions from the molten KBr, that is molten KBr, Br minus ion, they will move towards the anode, that is the positive electrode, and convert into bromine plus gives out 2 electrons. So this bromine will be produced at the 2Br minus will convert into Br2 gas or Br2 liquid. Doesn't matter, you can write gas or liquid both. If it's high temperature, it will convert into gaseous state. Br minus converts into Br2. This is the equation. Now name the product and the state and state the observation at the negative and the positive electrodes when dilute aqueous bromide. Now this question has another thing, which is dilute aqueous bromide. The bromide will have K plus and Br minus ions, but the water along with it, and it will also have H plus and OH ions, which are from water. That is, there will be 2 cations and 2 anions in my aqueous dilute potassium bromide solution. Now, what are the products at the negative electrode? As per this, the negative electrode, the positive ion will go to the negative electrode. Out of K plus and H plus, these are the 2 positive ions. H plus has more tendency to lose charge. Thus, H plus will go to the negative electrode and will accept 2 electrons, undergoes reduction to form hydrogen gas. This is produced at the negative electrode. Hydrogen gas will be produced at the negative electrode. Okay. State is asking, we have to write hydrogen gas. Observations at the negative electrode, when since hydrogen gas is produced, then there will be bubbles of hydrogen gas or effervescence of hydrogen gas is produced. Products at the positive electrode. Now here is a problem. Problem is that when we talk about aqueous potassium bromide, then the ions which will go to the positive electrode will be Br minus and OH minus both. Now, as per the syllabus of higher classes, Br has more tendency to lose charge. Thus, the product should be bromine. But in IGCSE, they generally what they do, they consider it a very dilute aqueous solution. Dilute means very dilute. And in case of very dilute aqueous solution, and they also had given you the 2 empty boxes in which we have to write 2 products. And these 2 products can be produced only when the OH ions will go and lose their charge and convert into oxygen and water. What I can write here is, I will write bromine, Br2 along with it, because bromine is actually the correct answer. But as per IB, which is accepting, or which I think should as per IB it is bromine, but IGCSE accepts it as water and oxygen gas. I had seen some of the MCQs where they are accepting water and oxygen gas, and some are accepting bromine. So these 2 should be the answer in the answer keys. I believe both will be there. Now observation at the positive electrode, if it is bromine, then reddish brown gas will be observed. Reddish brown gas or bubbles will be observed. Or if it is a oxygen gas, then colorless bubbles will be obtained. So I will write both colorless bubbles and reddish brown bubbles. Let me see what the answer key says when it comes. Okay. That's all about this question. Now the question number 3 is, the halogens are a group of elements in the periodic table and chlorine is a member of this group. State the group number of the halogens. Part A says state the group number of halogens. For this we require the periodic table that is given in your paper at the end. As we scroll down to the periodic table, we see that this periodic table has groups written here: first, second, third, fourth, fifth, sixth, seventh. So this is halogens and chlorine is a member of this group. It means this is talking about this group, which is my halogens. The word halogens means they are halo plus gens which are obtained from seawater. Basically these elements are obtained from seawater, therefore we call them halogens: fluorine, chlorine, bromine, iodine, astatine, and a new element added here is tensionine. This tensionine is a new element which is added here which is TS. This symbol is TS. It is called as tensionine. TENNESSINE. Tensionine. Tensionine is a new element added in this group. There are group number 7 of the periodic table, which are called as my halogens. To move back to the question, what we have to write? Question asking, what is the group number? State the group number of the halogens. So it is group number 7. 7 is my group number for the halogens. State the number of halogens. How many halogens are there in this group? Now earlier, when only astatine was there, the number of halogens would have been 5 only. Now with the addition of this new element, if we count 1, 2, 3, 4, 5, 6, the group has been completed. Now we have 6 elements. When we use this TS or tensionine, then it is 6 elements. For this question, you have to go to the periodic table and see if tensionine is added. Now since tensionine is added, I will write there are 6 elements in the periodic table of halogens, 6 including the TS, including my TS. Okay. Suggest the identity of the halogen which has the highest density. As we move down in halogens, the density goes on increasing. Thus, as per this data booklet, TS or tensionine should have TENNESSINE, tensionine or TS should have the highest density. But I hope astatine 80 they will also accept, because it is a new addition in the periodic tables and some books are still missing it. Therefore, a benefit of doubt can be given to you. You can also write astatine here. Most reactive. As we move down the group in this table from fluorine to tensionine, the reactivity goes on decreasing. Reactivity decreases. Hence, fluorine is my most reactive element. Reactivity, in terms of reactivity, fluorine is the answer. State in the name of negative ions formed by halogens. They form halide ions. Halogen forms halide ions. How many occupied electron shells are there in bromine atom? Now bromine will have, since bromine belongs to, how will you know this? For this you have to go to the periodic table back again, and that's a shortcut method of finding out. You find out the period number of bromine. The period number 2 fluorine, 3, 4. Since bromine belongs to the 4th period of the periodic table and this period number represents the number of shells, I can say bromine will have 4 shells. The period number will represent number of electron shell that has been filled. It can be found out by the help of period number. Now bromine belongs to the 4th period, therefore I can say 4 electron shell will be occupied. Name the noble gas with the same electronic configuration, Br minus ion. Now Br minus ion will accept 1 electron and it will have 8 electron outermost shell, and that will resemble the nearest noble gas, and the nearest noble gas for Br will be krypton. So it will be having same configuration like that of krypton, as you can see in this periodic table. Periodic table is required for this question. You have to scroll down again and again or turn your page for the periodic table. Br minus ion will have same electronic configuration like krypton, Kr. Kry, P2, and he's asking name, so we have to write the name. When they are asking name, we should write the name. Aqueous chlorine reacts with aqueous potassium iodide Ki, and one of the product formed is iodine. Now we know chlorine is more reactive than iodine. Thus, chlorine can displace iodine from its compounds and form its own. Complete and balanced ionic equation for the reaction between Cl2 and I minus ion, and the symbols not required. Okay. Now Cl2 will react with I minus to form Cl minus plus I2. Now there are 2 chlorine, we will write 2 Cl minus, 2 iodine, we will write 2 I minus. This will be my complete equation. Explain why this reaction is defined as a redox reaction. Now redox reactions are those in which oxidation and reduction takes place in simultaneously. Now in this reaction, chlorine is forming Cl minus ion, that is gain of electrons taking place. Gain is taking place. And I minus is forming I2 minus I2. I minus forming I2, that is loss of electrons taking place here. Now gain of electron is what? Reduction. And loss of electron is what? Oxidation. Since both are taking place here, therefore it is a redox reaction. So what I will write here? I will write Cl2. Cl2 is having what? Cl2 is gain electron, is accepting electron, and thus reduction is taking place. Cl2 is accepting electron or gaining electron to form chloride ion, Cl minus ion. Therefore, thus it is undergoing reduction. Whereas I minus ions are donating electron to form I2, thus oxidation takes place on it. Oxidation takes place on them. And since both oxidation and reaction are taking place, it is called as a redox reaction. Okay. Now give the color and the state of the iodine at room temperature and pressure. Now iodine color is purple, or we can say dark purple, which is almost black in color, so we can write purple black. And it is solid. It is a pseudo solid van der Waals solid. Van der Waals solid. So it is solid at room temperature, van der Waals solid. So it exists in form of crystals. State is solid. Now the fourth question is carbonyl chloride COCl2 is manufactured by reacting carbon monoxide with chlorine. CO with Cl2 forms COCl2, and delta H, which is my enthalpy of reaction, is minus 105 kilojoule per mole. What is minus tells? Reaction is exothermic in nature, negative means exothermic. The process takes place in a closed system and an equilibrium is achieved. Equilibrium is when the rate of forward and backward reaction is equal. The condition for this process are 200 degrees Celsius and 200 kilopascals. This is pressure and this is temperature. Okay. Now the first A part is explain what is meant by the term closed. Whenever I say closed, I take a beaker and close it and heat it from down. What is happening in this closed? Closed system means system in which no exchange of matter takes place between system and surrounding. No exchange of matter. Now this system, which is my beaker or whatever the reaction is taking place, that will not lose any matter. No exchange of matter. Matter remains constant. Matter constant. Matter remains constant. But there can be exchange of heat. But there can be exchange of heat. Exchange of heat between system and surrounding. Heat between system and surrounding. System and surrounding. Now there can be exchange of heat, that is a closed system, but matter will be constant. Next question is state what the symbol delta H represents. Delta H represents heat change. Heat change or enthalpy. We also called it enthalpy of reaction or enthalpy. So this delta H represents heat change, enthalpy, and the sign of delta H represents whether the reaction is exo or endo. For exothermic, delta H should be negative, and for endothermic, delta H should be positive. Okay. State how the value of delta H above. State how the value of delta H show that the forward reaction is exothermic. Now, if I see this reaction, we see delta H is negative, minus 105. Now, if delta H is negative, it means the forward reaction is exothermic. Delta H negative, exothermic reaction. And why a reaction is exothermic? This reason is the bond energy required to break the bonds in the reactants, the bond energy for breaking the bonds, bond energy for reactants is less than bond energy released during bond energy formation of products. The bond breaking requires less energy and bond formation gives out more energy, than a reaction is exothermic in nature. Deduce the value of delta H for the reverse reaction including sign. Now if I reverse this reaction, it means in the forward direction the reaction is exothermic, in the backward direction the reaction will be endothermic. Now for endothermic, delta H becomes positive. So what will the value? The value will be same, but the sign will be opposite. It will be plus 105 kilojoule per mole. That will be the answer for this. Okay. Now complete table, next E part. Complete table 4.1 to show the effect, if any, on the concentration of COCl2 at equilibrium when the following changes to the conditions are applied. And this question is based on now Lee-Chatelier's principle. Now it's a reversible reaction, and any change in the reversible reaction at equilibrium may result in disturbance of this equilibrium, which is governed by Lee-Chatelier's principle. Now we go to the first change to condition and effect. Temperature is increased. Now what we are doing, we are increasing temperature. Now as per this concept, if I increase temperature, as per Lee-Chatelier's principle, reaction should always go towards endothermic side. So whenever we increase temperature, reaction goes towards endothermic side. Now in this reaction, endothermic side is the backward direction. Therefore, if the reaction moves in backward direction, the concentration of COCl2 will decrease. So what will the answer for change in concentration? It will decrease, because the reaction moves in endothermic side, which is the backward direction. Some carbon monoxide is added. Now carbon monoxide is my reactant. If I increase the concentration of reactant as per Lee-Chatelier's principle, the reaction should move in forward direction so that the reactant concentration is increased. Now, as per Lee checklist principle, if reactants are increased, reaction should move in forward direction so that the added reactant can be used up. Hence, the effect of concentration of COCl2 at equilibrium will be, it will increase. More of COCl2 will be formed. The pressure is increased. If I talk about pressure, so whenever we see a reaction is gaseous, then only the pressure will affect. Now, all the reactants and products, they are gaseous. The reactant moles, there are 2 moles of reactant. If I see this reaction, there are 2 moles of the reactant gases and 1 mole of the product. 1 mole in the product side. 2 moles for the, if I read this question, there are 2 moles. If I write it here, I will write 2 moles of this, 1 plus 1, 2 mole of gases, and here it is 1 mole. When gases are less, pressure is low this side and pressure is high this side. Okay, products have low pressures compared to reactants. Now, products have low pressure, P low at product side. What I'm doing is, there are less number of moles to product side if I'm increasing pressure. So whenever you increase pressure, reaction always to move towards less mole side. What is the less mole side? Product. It means COCl2 concentration will again increase. It will form more of COCl2. Thus, if the pressure is increased as per our principle, the reaction should move towards forward direction. Why? Because there are 2 moles on the reactant side, 1 mole towards product side. It means their pressure is low, air pressure is high. And according to Lee-Chatter's principle, if you increase pressure, the reaction should move towards low mole side, which is my forward direction. Hence, COCl2 concentration will increase. This should be the answer. Pressure is increased, the COCl2 concentration should increase. Next is, if a catalyst is added. Now, catalysts do not affect the equilibrium concentrations. It can help in reaching equilibrium quickly, but it do not affect. Hence, there will be no change for this question. No change will be the answer. Got it? Now, F part of this question says, the equation for the reaction can be represented as shown in figure 4.1. Here it is a C triple bond O, which is carbon monoxide, combined with Cl2, which is ClCl, and forms C double bond O, Cl2, that is carbonyl chloride. And the heat of the reaction is 105, that is minus 105 exothermic. Reaction is exothermic in nature. By using the table 4.2, which has bond energy of C double bond, triple bond O, ClCl and CCl. ClCl is 240, CCl is 340, chlorine bond is 240 and carbon and chlorine bond is 340. C triple bond O carbon monoxide bond is 1075 kilojoule per mole is the energy required. Now we have to use this table in bond energy in table 4.2 and the value of delta H, which is given in the reaction, to calculate the bond energy of C double bond O bond. That is, I want this bond energy. This I have to find it out. For this I require the bond energy of my product and then I can do it. The steps which they are given in the question is, calculate the energy needed to break the bonds. That is, bond energy of reactant we have to find out. We have to find out the energy needed to break the bonds. Bond energy BE of reactant we have to find out. And that will be equal to, what are the reactant? One is carbon monoxide, second is C chlorine. Now, it will be equal to C triple bond O bond energy plus 1 chlorine bond energy. C triple bond O bond energy as per the data booklet is 10 of this your table is 1075 plus chlorine bond energy is 240 kilojoule. The sum total for the bond energy, that is the bond broken, that the sum total of the bond energy, which is the bond broken, comes out to be 1075 plus 240, that is equal to, if I calculate, is 1315. This will be the answer. 1315 kilojoule is my answer. Okay. Bond energy of carbon monoxide plus bond energy of the chlorine molecule will give you the bond energy of reactant, which is we find it out. Now calculate the energy released when the bonds in carbonyl chlorides are formed. That is, we have to find out the bond energy of the product. Now we don't have the bond energy of C double bond O. Thus what we have to do, we have to find out by the help of this formula, delta H equals to bond broken, that is bond energy of reactant, minus bond formed, which is bond energy of my products. This we have to find it out. Delta H of the reaction is minus 105. Minus 105 equals to bond energy of reactant is 1315, which we have calculated, minus bond energy of products. Okay. By the help of this, if I find it out, if I use this to find out then bond energy of product will be equals to 1315. Rearranging this, I will get 1315, and it comes out to plus 105. I'll take this bond energy here and bring this here, so it will get plus and this will get plus. That comes out to be equal to, if I add it, it comes out to be 1420 kilojoule. That's the answer. That is, the bond energy of the products is 1420 kilojoule. Now calculate the bond energy of the CO bond. For the CO bond, we know that bond energy of products will be equal to the bond energy of the carbonyl chloride, which is one bond of C double bond O and two bonds of CCl bonds. It will be C double bond O bond plus twice into CCl bond, carbon chlorine bond. C double bond O we have to calculate, that is equals to X, and bond energy of products from the first upper part is 1420 plus bond energy of the carbon chlorine bond. Carbon chlorine bond energy is 340 plus 342 into 340, that comes out to be X plus 680. 1420 equals to X plus 680, and then X, which is the C double bond O bond energy, that comes out to be 1420 minus 680. 1420 minus 680, and that is equals to 740 kilojoule per mole. This will be the answer for this part. Next part of this question is complete the dot and cross diagram for the molecule of carbonyl chloride showing outer shell electron only. Now carbon has 4 outermost shell electron. Out of this, one is it is forming with chlorine a bond. It is forming a double bond with oxygen, and one it is sharing with this chlorine. Chlorine has 7 electron outermost shell, 1 it is sharing with carbon, and 6 will be here. 1, 2, 3, 4, and this is 5 and 6. These are for this chlorine. Similarly, 1, 2, 3, 4, 5, 6 for this chlorine, and 1 it is shared. Oxygen has 6 electrons outermost shell. Out of that, it has shared 2 electrons with carbon. The oxygen will have 1, 2, 3, 4, and then 5 and then 6. This will be the diagram of CCl, C double bond O, ClCl, carbonyl chloride. Okay. Now question 5th. Manganese is the element with atomic number 25 in the periodic table, and calcium is the element with atomic number 20 in the periodic table. Complete the table 5.1 to show the number of protons, neutrons, and electrons in Mn55 and Ca2 plus 44 ion. One is Mn. The atomic number of Mn is 25. So I'll write 25 here. Atomic number of calcium is 20. I'll write 20 here. Okay. Now protons is equal to the number of the atomic number. Proton in an element is equal to atomic number. Therefore, Mn will have 25 proton and calcium will have 20 protons. Okay. Neutrons is equal to the mass number. Mass number is 55. 55 minus the atomic number, which is 25, that gives you the number of neutrons, that is 30. 30 for this, and 42 minus 42 minus 42 minus 20, that comes out to be 22. 22 for calcium. Now since calcium is losing 2 electrons, therefore its proton will not be equal to electron. It will have 2 electron less positive ion, therefore 18 electron in calcium. And Mn have proton 25 is neutral, therefore the number of electron is also will 25. The B part of this question says manganese forms several oxides, and the formula of some of these oxides is given: MnO, Mn2O3, Mn3O4, MnO2, and Mn2O7, etc. Suggest why manganese is expected to form colored oxides. So when he's saying colored oxides, so as we know, colored oxides are basically formed by transition metal. Therefore, it isn't transition metal. We can see in the periodic table also, it is a transition metal. That should be the answer for this question. Next, state which other property of manganese is shown by the formation of several oxides. Now, as we see in these oxides, manganese have different oxidation state. For example, +2, then plus 3 here, then plus 7 here, and so on. So it has different oxidation states. It has different oxidation state, or we can say variable oxidation state. The answer for this will be variable oxidation state. That is another property of transition metals. They show variable oxidation state, thus they can form many types of compounds. State the formula of manganese 2 oxide. Manganese 2 oxide. Now manganese 2 means the charge of manganese is 2, and in this case I can find out X plus oxygen is minus 2, oxidation number equals to 0, then Mn comes out to be plus 2. It means it is Mn2 oxide. Now the formula for this is MnO. Okay. Mn3O4 is found in an ore of manganese. Manganese metal can be extracted from Mn3O4 using aluminium as a reducing agent. Suggest the term reducing agent. Now, our agent is which works for others. So what a reducing agent will do? Agent reduces others that itself get oxidized. So the chemical species which donates electron to other species, and thus reduces them. Itself get oxidized, and itself gets oxidized. A reducing agent reduces others and itself get oxidized. Okay, that should be the answer for this. Complete the symbol equation by inserting the formula of the missing products and balancing the equation. Now Mn3O4, I have to balance it. Gives you Mn, and a product is also missing. So when I react Mn3O4 with aluminium, we know it should form aluminium oxide. Al2O3 will be my formula. Now when aluminium there are 2, if I put 2 here, then it will be 2 aluminium, but oxygen will be 3 only. So we have to take oxygen also in whole numbers. So what I have to add? I have to add, if I put 2, then 2, 3, 4, 12. I will put a 3 here. 3 Mn3O4 gives you 3, 4 are 12. Then 12 oxygen, it means I can put 2 here. No, I have to put 4 here. I'll put 4 here. If I put 4, then it will be 12 oxygen. 3, 4, 12, 4, 3, 12 oxygen balanced. Mn is 3 into 3, 9. I'll put 9 here. And aluminium are 8 and 8 here. This will be the least possible balancing. 3, 8, 4, 9. That will be the balancing of this equation. Next part is MnO2 reacts with dilute HCl. In the equation, MnO2 plus HCl, 4HCl give you MnCl2 plus 2O plus Cl2. H2O plus Cl2. Calculate the volume of chlorine gas formed in centimeter cube at RTP. When excess MnO2 reacts with 50 centimeter cube of 0.2 mole HCl. So it is in excess, and we have the concentration and volume of HCl. Therefore, find the moles of HCl. We know that concentration equals to N upon V, that is N equals to C into V. Concentration equals to number of moles upon volume, and number of moles equal to concentration into volume. Now, concentration of HCl given is 0.2. N to volume is 50 centimeter cube. Volume always required in dm cube or liters. Therefore, it is 50 upon 1000. What will be the answer? It will be 0.01 mole. 0.01 mole. That will be the answer. Okay. This 0.01 mole. This goes, and it is 0.2. One more. It is 0.01. Okay. Now determine the number of moles of chlorine formed. According to this equation, 1 mole MnO2 gives you reacts with 4 moles of HCl, 4 mole HCl, and gives us 1 mole of chlorine, 1 mole chlorine. It means the ratio between HCl and chlorine, if I have to find out, because they are asking chlorine, then the ratio between HCl and chlorine is 4 mole of HCl gives you 1 mole chlorine. Thus, what moles I have? I have 0.01. 0.01 will give you how much? 0.01 upon 4. That comes out to be 0.0025 mole is the answer for this question. Calculate the volume of Cl2 formed. Now, as per the question, as per this, volume of a gas at RTP is equal to moles of the gas into 24 dm3, which is my RTP volume for 1 mole. Moles is 0.0025 into 24. By 1000 I do, and I will get 60 centimeter cubes, because my answer required is in centimeter cube. Got it? Describe the test for chlorine. chlorine gas we have to test. Now whenever we pass moist gas, chlorine gas or moist litmus, we called it damp blue litmus test. Damp blue litmus test. Yeah, damp litmus test. What we do in this, we pass the chlorine gas over damp blue litmus paper. Observation is it turns red. First it will turn red and then it bleaches out. Bleaches, that turns white again. Why? Because the HCl is formed when we pass chlorine or damp litmus paper. First it will form HCl, which will turn the litmus paper red, and then one more compound is called HOCl, which bleaches it, which is a course of higher studies, then you will know there. Okay. Explain in terms of collision theory why decreasing the temperature decreases the rate of this reaction. Now, for a general reaction, if temperature of a reaction is decreased, then what will happen? The decrease in temperature will result in decrease in kinetic energy. The kinetic energy of reactants will decrease. When the kinetic energy of reactant will decrease, there will be less chance or there will be less number of decreases. Thus, number of collisions per unit time is called as frequency. Collisions or frequency of collisions will decrease. And when the number of collisions or frequency of collisions decreasing, chances of successful collision also decreases, because only successful collision results in products. Thus chances of successful collision will decrease, and when the chances of successful collision decreases, the rate of reaction will decrease. Okay, will decrease. So we can say decreasing temperature, if temperature decreases, the rate will decrease. Okay. 6 is the structural formula of two compounds A and B are given here. A is CH2 double bond CH CH3 and B is CH3 CH double bond CH CH3. This is my propane, double bond is there, and this is butene because double bond is on second carbon, butene. A and B, they are the members of same homologous series. Yes, they are the members of alkene series. Now, give two reasons why the structural formula of A and B show they are members of same homologous series. How this structural formula show? The structural formula showing they have a general form, they have a double bond. So both have a double bond, that is they have a same functional group. We can say, or both have a double bond group, or both are double bonded compounds, and the general formula both of them is CnH2n. General formula CnH2n. We can also write both of them, the formula for first is C3H6 and for the second is C4H8, and both of them differ by a CH2 group. So we can also write differ by a CH2 group. So these could be 2-3 points. Same functional group, or both contain a double bonded compounds, both contain double bonds. They have same general formula, which is CnH2n. One is C3H6, other is C4H8, or that is they differ by a CH2 group, which is the property of a homologous series. Explain why A and B are both hydrocarbons. Both contain carbon and hydrogen. Thus, a CH bond is present. Okay. Write the symbol equation for the complete combustion of A. Now A is my CH2 CH3, that is C3H6. So when I write C3H6 propene, which is the gas, plus complete combustion, oxygen is required. In presence of oxygen, it will undergo, it will form complete combustion, always form carbon dioxide and water. CO2 plus H2 is always formed. When we balance it, If I put 2 here, and then it will be 6 of CO2 and then 6 of H2O. Therefore, oxygen will be 12, 6, 18, 9 O2. This is complete combustion equation 1 mole. Deduce the empirical formula of A. Now, when we talk about the empirical formula, it is C3H6. The formula for A is C3H6, and empirical formula is by dividing it by the common number, which is 3, I get a CH2. Empirical formula for this is CH2. Divide the molecular formula by a common number, and the common number is 3. So when I divide this C3H6 by 3, I will get C1H2, that is CH2 is my empirical formula. Name compound B. Now compound B, a double bond is present on the second position and it has 4 carbon. Therefore, I written the name butene. The name of this compound is butene. You should write in this way, butene. Position of double bond is required. Structural isomer of B is the member of the same homogeneous series. Draw the displayed formula for the structural isomer of B. Now the isomer of B could be but1ene. But1ene could be the structural isomer of this compound. So we have to put double bond on the first carbon and then 4 carbon atoms, then 2 hydrogen here, 1 here, 1 and 1, 2 here, and 3 here. This will be the structural formula but1ene. The next part of this question is compound B reacts with aqueous bromine at room temperature to form product C. The equation is shown below, in which this bromine is reacting with but2ene to form 1, 2, 3, 4, 2,3 dibromobutane. This is the name of this compound. And state why this reaction is addition reaction. As we can see in this reaction, but2ene is reacting with bromine to form one compound, single compound. This reaction is addition because a single compound is formed by addition of bromine to the double bonded carbon atoms. That's why it's an addition reaction. Describe the color change in aqueous bromine during this reaction. Now, aqueous bromine is reddish brown in color. From reddish brown, it turns to colorless. This is a test of unsaturation in which all double bonded carbon atoms, like alkenes and alkynes, double bonded, triple bonded, when they react with aqueous bromine, they decolorize it. Now the product formed, as we are already written above, it is 2,3 dibromobutane. Answer is 2,3 dibromobutane. This is the answer for this compound. Okay. Under certain conditions, 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. 1 mole of B reacts with oxygen to form 2 moles of carboxylic acid D. Carboxylic acid D has 2 carbon atoms. We don't require these conditions. It takes place. Draw the displayed formula of carboxylic acid D. So it will form 2 carbon atom carboxylic acid, and when the 2 carbon atom carboxylic acid will first make the carboxylic acid group C double bond OH. C double bond O and OH. This is the formula, and 2 carbon, 1 carbon more, and this carbon is 4 valencies, 4 hydrogen will satisfy it. The formula is CS3COOH. This will be the formula for the carboxylic acid form, 2 carbon atom. Name of this carboxylic acid, 2 carbon carboxylic acid, is called ethane, and then oic acid. Name is ethanoic acid is the name of this 2 carbon carboxylic acid. Complete the symbol equation for this reaction. Now when I react this ethene, this but2ene with oxygen, symbol equation is O2. What it's forming? It is forming CH3COOH. So when I have to balance it, there will be, if I put 2 here, because there are 4 carbon atoms, then 2, and then oxygen will be 2 into 2, 4. So I'll put here 2. I think this will be the balance equation for this question. Okay, in this way we had completed this paper, and as per discussion with the teachers. This paper is not so tough. It is an easy paper. I hope most of you will score a A star in this paper. This is a very good paper, very easy paper. Thank you very much for watching.